Hello, everyone, and welcome. My name is Brian Mendez, and I am from the University of California, Berkeley, where I am the planetarium director. And this week is Space Weather Explorers Week, where space scientists can answer your questions about the Sun-Earth connections and life as a scientist. You can see all of that information at spaceweather.ssl.berkeley.edu. Welcome to our live webinar featuring Dr. Patricia Reiff, who's from Rice University. Today's webinar is called Tricks and Tips for Observing an Eclipse. This webinar will last up to 60 minutes, and you are encouraged to ask questions along the way. Your microphone is muted and webcam off, so you can ask questions using the Q&A box throughout the webinar. If you don't see that on your screen at the moment, just move your cursor around and it'll show up at one of the edges of your screen. This webinar is being recorded and we will share the recording afterward. So let me introduce to you our speaker for today. Dr. Patricia Reiff is a space plasma physicist and professor of physics and astronomy at Rice University in Houston, Texas. She has served on the science teams for several NASA missions studying Earth's space environment, including the Dynamic Explorer, Polar, Image, Cluster 2, and MMS, to name a few. She's also developed the Discovery Dome portable planetarium system and the Space Update software that reaches millions of people through museums and outreach events. She's also served on advisory committees for the National Science Foundation, NASA, and the National Academy of Sciences, among many other professional space science organizations. Her first total solar eclipse was the one that went through Winnipeg, Canada in 1979, and she's been hooked ever since, observing well over a dozen solar eclipses ever since. And so she will share now with you some of the wisdom she has gained in all that experience. So welcome very much, Pat.
Hi, good to be here. Always fun to talk to folks, and this is a very appropriate time because we're all on pins and needles, hoping that the weather is going to break, but you never know. I always tell people don't give up because even though it might look a little bleak at this point, I live in Texas and the weather can change in 15 minutes, and these models are really good, but we're still almost a week out. And so models change, data changes, and the timing of cold fronts are going to be really important as to whether we can see the eclipse or not. So my first statement is don't give up, okay? On the other hand, if you are mobile and you do look at the weather forecasts, and right now New England's looking better than Texas, which is unusual. Then make your plans accordingly if you can. If you can be mobile, go for where there's no clouds, because ultimately the best view of an eclipse is one that's not through clouds. And I have been clouded out, so I'll tell you a few things you can do even if you are clouded out. But hopefully it will be good for everybody. So I've got a few slides in a PowerPoint I'm going to show you here. And first, I'm going to share the screen. I have learned to do that first. All right. And then I'll start the PowerPoint. So I may not be able to see the Q&A when I'm in the middle of the PowerPoint, but Brian will help me out with that. All right. Where is the... There we go. All right. Everybody can see that okay? Hope. Can everybody see that?
Yes, we can. Thank you.
All right. So ultimately, we really want it to be clear, but there are some fun things you can do even if it's cloudy or even worse, rainy. So let's talk a little bit about what we're going to be able to see. So why is it not going? Okay, so on April 8th, by now you all know there's going to be a total eclipse crossing the US. The last one was in 2017, and I was in Wyoming, and it was one of those perfect days where you get to see this beautiful sunset all the way around you, the glorious solar eclipse up high in the sky, and even a few planets. Um, and when you look at the eclipse with a good pair of binoculars, this is the perception that you get. Okay, you see the structure of the sun. What looks like you're actually seeing the magnetic field lines, and in effect, you are, because electrons can flow up and down along field lines freely. And so if you've got a hot source on the sun, it lights up that field line all the way out. And if the magnetic field line is closed, then it acts like a bottle, and you're bottling up the electrons, and you're getting higher and higher densities. So most of the corona light that we see is actually regular solar sunlight that's scattered by these electrons that are cycling around the magnetic field. So this, as I said, is pretty good of what your eyes see when you look at a total eclipse with the binoculars. Now, can you get a good picture like that with your camera? Unfortunately, your camera doesn't have that HDR effect that your eyes do. So when you're taking pictures, you're going to want to take short time exposures to get the inner corona and these beautiful red prominences, and then longer and longer time exposures get the outer corona, but at that same time, it's overexposing the inner corona. So long and short of it, enjoy it. Don't worry about getting the perfect picture. Somebody else will do a better job than you can. So enjoy it if you can see it. And it is just, amazingly enjoyable. Now, one thing they did is they took off their filter a little before totality. So if you've got a camera or a video camera that has a LCD panel, not a through the eyepiece viewfinder, then you can take your filters off just a little bit early, and you'll see the diamond ring going to the Bailey's beads and then going to totality. So here's what I'm saying about having a short exposure. You get the inner corona, and then as he'll open it up, and you'll see more of the corona as you increase the exposure. But this is a kind of a typical view that you'd get from a video camera. You see how he's increasing the iris, and it's now overexposing the inner corona. Okay, so here's the path of totality. You may have seen in the news yesterday that NASA has, adjusted the path of totality. And there were a couple of April Fool's ones that had, going up the eastern seaboard. Those were April Fools. What was true is that, the edge of the moon has mountains on it. And so this outer edge of totality is a little subject to those mountains and valleys on the edge of the moon. So if you want to get a total eclipse experience, you don't want to be close to the edges. You want to be well inside. But generally speaking, if you're in the middle, 2/3 or 3/4, you're golden. You don't have to worry about the minor corrections that they just came out with. But you do need to prepare. So, if you've got an event going on, you got to prepare for traffic, prepare for the sun going away, watch out for lights that come out on dusk. There's going to be tremendous traffic. There's going to be crowds. But it is an option to really educate the public and get them excited about solar physics. And yeah, if it's cloudy, there are some things that you can do, and I'll talk about a few of them. Now, the things you should have done 2 years ago is to plan your trip. But even now, there are still things you can do about getting a good pair of binoculars, making sure you've got eclipse glasses, making sure you have water, making sure your gas tank is full. because there's going to be a lot of traffic. And so be aware that you may be stuck in traffic for a few hours. Um, for this one, there'll be the path of totality is actually going over quite a few cities. And so there's like 30 million people that live in the path of totality, and even more that will be coming to visit. Now this was our predictions of of the weather for the eclipse, and for that, Mexico was predicted to have only a 25% chance of cloudiness, and Texas was more like 50% chance of cloudiness, and New England was more like 80% chance of cloudiness. But this is what you expect, and weather's what you get, and right now, this is the forecast, which may not only be clouds, but actually rain over a lot of Texas. Maybe Eagle Pass will be available. Arkansas looks good, and Indiana, and again up through Vermont and Maine looks at the moment like it could be good. But again, don't be surprised. Forecasts change. Uh, Okay, so and if you miss this one, the next one's going to be a while. Okay. So this was the one from 2017. Here's the one next Monday. This is the next one touching the United States, and it will be in 2044, and only, North Dakota and Wyoming. But there'll be another good one crossing the United States in 2045. So 21 years from now, we'll have another good one crossing the United States. So, don't miss this one because it's going to be a while for the next one. And this is the similar paths of the annulars. All right, so the question is, how do I find out what the percentage is going to be at any particular given location? And this is my favorite. It's called timeanddate.com/eclipse. And if you're in a town, you can put in your town name. But if you're in a city that's big, or if you're not in a city at all, it has a map, so you can drill down to your location, and it will show you what percentage of totality you'll have in your location. Now, I just said it wrong. Okay, I said percentage of totality. There's no such thing as percentage of totality. It's either total or it's not. There's a percentage of solar coverage. Okay. So in Houston, for example, the solar coverage is going to be 94%. Okay. That means it's going to start to get dark in Houston. But will it be totality? No. It won't be totality at 98% either. 99%, no. If you want to see the corona, you've got to go into the path of totality, because only in the path of totality do you really get to see what this is all about. One, it's the difference between seeing a picture of the Grand Canyon and riding a rubber raft down the river. It's a whole body experience and not just your eyes. All right, so eclipse safety is absolutely tantamount. The first contact will be when the first bit of the moon starts to cover the sun. And this is the partial phase. And for us, it's going to be about an hour and a quarter in the partial phase. And then the diamond ring and the Bailey's beads are where the second contact is the beginning of totality. So you can take photos without filters for a minute or so before it's okay to view with your naked eyes or binoculars or telescopes, only during the totality. And don't even look at the diamond ring with your naked eye either, because it will kill your night vision. So if you really want to sneak a peek at the diamond ring, do it on the way out, not on the way in. And then there's another an hour and a quarter of the partial phases coming out. So if you're not in the path of totality, you won't get this middle part. You'll just get a partial and then it'll go back away, and you miss out on the totality. The question is, why do eclipses have to be during full or new moons? Okay. And that really has to do with the alignment, and I'll talk about that in just a minute. So here's an example of timeanddate.com, and I put in Houston, and it shows the maximum coverage, and down below it, it's got the maximum timing, and you can use this slider to see how the sun is going to look like in your location. So for us, the altitude is going to be 67 degrees, which is really high in the sky, and the direction is almost just 10 degrees west of south. So for many places in Texas, the totality is going to be right at solar noon. Okay. But guess what? The weather right now doesn't look good, but who knows? Um, and then if you are in a place that has totality, it will then tell you the times and directions to look. And this is really handy because if you want to make a really cool picture of the totality in the sky, you want to know where it's going to be in the sky. So altitude is the angle above the horizon. Azimuth is the direction around the horizon. North is 0, east is 90, south is 180, west is 270, and north is 0 again. Okay, so for most of us in Texas, it'll be nearly south. As you go further to the northeast, it will be more toward the west. Okay, but this is a good place to get the timings that are appropriate for your location in your own uh, uh, time zone. Now, if you don't, if you're not in a good city, you can go to their map function and slide yourself in and keep, keep increasing the map like any good Google map and find your spot and find out then how long the totality will be in your location. So even though this one is not near the center line, it's still almost 2.5 minutes worth of totality. So totality is pretty broad, but you don't want to get too close to the edges. Okay, so if I'm going to say one thing, go to totality if you at all can, but try to stay overnight the night before and the night after to avoid traffic because the traffic is going to be crazy. Now, if it's raining, maybe the traffic will be less. So that actually might be a blessing. Who knows? This kind of shows you how the 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 time of totality goes across the path. So in Texas, our maximum is 4 minutes and 25 seconds, but you notice you get 4 minutes of totality for the entire middle half of this path and 3 minutes for the middle 2/3. So as long as you don't get too close to the edges, you'll get a pretty decent view, assuming the skies are clear. Okay, so like downtown Austin is not a good idea, but you can go to the suburbs and get a good view. Same thing with San Antonio, no totality in downtown San Antonio. Now, this was a friend took this off of his phone after the 2017 eclipse, just to give you a feeling for the traffic. So this you can tell the path of totality from the 2017 eclipse by just looking at how the traffic was just after totality. Okay, so what is a total eclipse versus an annular eclipse? Well, a solar eclipse is when the moon casts its shadow on the earth. A lunar eclipse is the earth casting its shadow on the moon. And totality moon means the entire sun will be blocked by the moon, allowing us to see the corona. Only during totality is it safe to view with naked eyes. So this is the t-shirt I wear when I do this around kids. So for a solar eclipse, you have the sun shining on the moon and that moon shadow hitting the earth. Whereas a lunar eclipse, you have the sun shining on the earth and the earth's shadow is on the moon. Okay. So what phase of the moon is this? Well, it's the same direction as the sun. So this is new moon. So a solar eclipse always has to happen near new moon. But a lunar eclipse, because it's the Earth's shadow on the moon, always happens at full moon. And if the sun gets between the Earth and the moon, then we're toast. Okay, so this is now a little better version of that diagram. It's still not to scale, but a little bit better. All of these diagrams you can download from my website. I've got tons of animations and graphics and even this presentation on eclipse observing tips. There's a 30-minute one I did outside, so you can actually see me demonstrating some of my favorite equipment. But so the lunar eclipse occurs at full moon, and the reason it's red is the sunlight that reaches it is scattered through the Earth's atmosphere, and the blue light is scattered away. Whereas in a solar eclipse, it's the moon's shadow on the Earth, and because the moon is so small, the shadow path varies from being infinitesimally small to being 150 miles wide or so. So we're getting one of the longer ones for this one, for which we're grateful. But if the moon is a little too far away, then the umbra doesn't quite reach the Earth. And so the moon, even though it tries to cover up the sun, it's missing part of it. So the only time it's safe to see the sun, of course, with naked eyes is right at sunrise and sunset. This is not going to be the case for this eclipse, so be prepared to have eye protection. Now, some of my favorite ways to observe the eclipse include, putting a filter in front of your iPhone camera. There's a nice apps to do that. You can put filters on top of binoculars, and this is an image that was taken by a smartphone through a pair of binoculars with a filter on it. And then this is what's called a sun spotter that projects an image of the sun. And this really works well, but it's a little expensive. So the question is it safe to watch a partial eclipse with sunglasses? No, 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 no. Not sunglasses. Sunglasses are not dark enough. You have to use special eclipse glasses in the partial, all the partial, okay? And that includes annular. The only time you can look at the sun directly is only during totality and only if you're in the path of totality. So if you're only in partial, you cannot stare at that sun directly or it will burn a crescent in your retinas. Really, really important. Now, so this is a little movie I did on solar versus eclipse, lunar eclipse geometry.
Sun, its shadow crosses the Earth. The deepest part of the shadow is called the umbra. People in the umbra see a total solar eclipse. It takes about an hour for the shadow to cross the Earth. 2 weeks later, the full moon can cross into Earth's umbra. Since the Earth is 4 times the diameter of the moon, the umbra is also 4 times larger, or 16 times the area. So, lunar eclipses are more common than solar eclipses. Everyone on the night side of Earth can see a total lunar eclipse, but only people in the narrow strip of totality can see a total solar eclipse. So, not only are lunar eclipses more common, more people can observe each one.
Okay, and there was a question about sharing my PowerPoint. Yes, I have a couple of PowerPoints already posted on my website, space.rice.edu/training/eclipse/training. And so you can download the PowerPoint. I tweak it, so it's, probably one from a month ago and not from today, but you're certainly welcome to download the PowerPoint that's there and also all of these animations. So here's what it's going to look like. Prominences are red loops around the edges. The trapped coronal loops build up the electron flux, so they're going to be brighter. These are called helmet streamers because they kind of look like the helmet of a German army officer. And the polar plumes are where the magnetic field stretches out into space. Now, one of the cool things about this one is every planet in the solar system and 3 of the minor planets are all going to be up in the sky. Again, assuming you're at a dark sky location and the clouds don't get in the way. So, under normal circumstances, you should be able to see Jupiter and Venus, maybe Mercury, maybe Saturn and Mars, again, depending on how dark the skies are. There is a comet that's over here near Jupiter that may be visible again if you've got a good clear sky. That's all within a 90-degree swath of the sky. And if you look, even some of the minor planets, so here is Ceres, there is Eris, and there is Pluto. So all the major planets and even the top 3 dwarf planets are all within a 90-degree segment of the solar system. So, who knows? There may be earthquakes. That would be interesting. But what it says is that people in China are going to be on the far side of the solar system. Will you see the diamond ring if you wear protective glasses? Yeah, you'll see it just as the sun going away. But what I would recommend for people for the diamond ring, okay? There's a diamond ring at the beginning and a diamond ring at the end. We actually might in Texas get at where we are, might see a double diamond ring, which is kind of cool. But what I recommend for people to do is not to look directly at the diamond ring without your glasses or even with your glasses. I would take pictures with your camera, okay? But what I would do and what I recommend people to do rather than to look at the diamond ring coming in is to actually watch for the moon's shadow coming at you. For us, it's going to be coming from the southwest, okay? So the sun's going to be in the south, but the shadow's actually coming from the southwest. And you will see that looking like a giant tornado that just gets bigger and bigger and bigger until it washes over you. And when that cloud, that giant shadow washes over you, then you are in totality. And that is an amazing, amazing rush. Well, earthquakes, I mean, when you have the sun and moon in an align, you call it a spring tide, which means the tides of the moon add to the tides of the sun. And so the tides are larger, okay? But it also stretches the earth a little bit. So if there's an earthquake that's almost ready to go, it's not going to create an earthquake, okay? But if there was an earthquake that's almost ready to go, it's trying to slip, but it's got too much friction to slip. That extra tide might just let it go enough that it will jump. And so it won't create earthquakes, but there might be an earthquake that happens during the course of this event that would have happened at some time in the next year, but because those tides are adding up. So, I mean, we also add in the tide of Venus and Saturn, but their tides are really quite low on the Earth. The strongest tide on the Earth is really just the moon, and then the sun adds to it. So here's the comet that might be visible. It's comet 12P. It actually is naked eye right now if you're in a good dark sky. Here, this was a picture of it with the Andromeda galaxy. Now here's what the prediction of the corona is going to be. So if you go to predictivescience.com, predsci.com, they use magnetic models of the magnetism at the sun's surface and predict what the corona is going to look like. And so this is, it's the corona is going to be nearly all the way around because we are at solar maximum instead of solar minimum. But it's definitely predicted to be pretty spiky as opposed to nearly uniform all the way around. Now, if you look at the sun in polarized light, which is what we're going to be doing with Citizen Kate, okay? The reason that the corona is polarized is those electrons are going around the magnetic field and they are scattering sunlight, and the polarization that you see is perpendicular to the local magnetic field. So the polarization here is in this direction. And if we color code, cyan to be this direction, then it's that polarization here and that polarization there. And similarly, yellow is polarization that looks like this. And so the polarization is this way near the surface and that way apart from the surface. But there's some details because of the magnetic fields are not truly radial. So that's one of the things that Citizen Kate is going to be doing, is taking images of the sun in polarized light, and we'll be able to create an image that looks like that from our telescope network. Okay, so we have a totality planetarium show that you can watch on our YouTube channel, and it tells a lot of the history, including the last one that went through Texas was in 1878. This one just missed Texas in 1919. So there's a lot of really cool historical, interesting things that have happened when the ancients went to look at the corona. They had long refractors, and so to get a long focal length, you had to have a long a telescope. Now, one thing that Edison tried to do, and this is him here, was to measure the coronal light, to try to measure the temperature of the corona, and he set up in a chicken coop. But unfortunately, what happened was, as it got dark, the chickens came home to roost and messed up all of his experiments. Similarly, another fun thing, in 1919, they measured the diffraction of the starlight during a total eclipse, and proved general relativity in a eclipse in Brazil. Another fun thing that people did was to um, to to sketch the corona during the eclipse. And this one in 1860 had this round part of the corona, which I'm sure everybody thought was really, really crazy. We now know that the corona pieces of the corona can actually break off and blast into space in what we call a coronal mass ejection. And there'll be a lot of observers monitoring the sun to see if we've got a coronal mass ejection happening during this totality. And if they're going off the side, they're not coming our way. But if they're expanding as we're looking at it, then they can run into us. So here's a picture of the shadow crossing Australia for the 2023 eclipse. So the totality really was only on one little teeny tiny section of Australia, but the shadow was really everything that was 90% and more. So I can't answer that one. Sorry about that. Another piece of citizen science is to measure the ionospheric flow. Is to measure the ionospheric flow, and as the shadow crosses the country, the ionosphere no longer is being ionized by the sunlight, and so the density of the ionosphere, which is quite bright before the eclipse, as the shadow is crossing, the ionospheric density drops precipitously, and a network of observers will be monitoring this upcoming eclipse this time as well by looking at GPS. And this is something that you can do even if there's clouds, which is nice. So one of the fun things you're going to see is sunset all the way around you, because these areas are not in totality. Okay, so this was one I called Dragon Eats Sun because it was a, 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 a cloud that kind of looked like a dragon's head. We actually had to jump in a bus and move a couple of miles to get out from under that cloud. I mean, but there's some wonderful uh, circumstances. You can see them at dawn, you can see them at dusk, you can see them from ships. And so I've seen 17 total eclipses, and I've only been clouded out 3 times. Now, this was one of the very best eclipses totals I ever was, and that was in Libya in 2006, and it was near noon local time. And guess what? This eclipse is in the same Saros cycle. Every 18 years, 11 days, and 8 hours, you'll get an eclipse of the same type. So the eclipse that I saw in Libya in 2006 is a duplicate, essentially, of the one that we're going to be having next Monday. And now, here's a case where when we got up, it was overcast, still seemed to be a lot of clouds in the sky. But as totality approaches and the sunlight um, is blocked, the cumulus clouds actually start to dissipate, and the high cirrus clouds become more transparent. So even though this looked pretty awful, we got to see the eclipse kind of coming in and out of the clouds. So it was a success, but it was definitely, a nail biter. Now, this one, on the other hand, which was during a raging thunderstorm, uh, we got rained out, and that happens. But what you see is, it still got dark. All the city lights turned on. This was in the middle of the day. So even though this was completely overcast and it rained on and off right before and right after totality, we still got an interesting view that it did get dark. Now, if you have a solar minimum eclipse, the corona is near the equator. If you get a long enough time exposure, I'll even see the markings on the moon itself because it's lit by Earthshine. Whereas this was one from Australia in 2023, and it was much more symmetric because we're closer to solar maximum. All right. So, what what do you experience? And this is important because if it's not clear, you'll still experience a lot of these same things. The wind can pick up, or the winds can die, the temperature falls, the animals start to roost, the crickets might start chirping. And so there are things that you experience with your body that not necessarily with your eyes. The diamond rings, I think, are some of the most photogenic. But again, as I said, better to do this with your camera than with your eye. And by looking at the sun's magnetic field, then we see the energy that is coming from the sun is being transported in these convection bubbles, and that's what heats the corona to millions of degrees. Okay, well, I'm going to skip over to some observing techniques and some citizen science. So this is a cool citizen science project where you look at the line emission from the corona, and the red is 2 million, and the green is 3.6 million degrees because this is more highly ionized. And what you see is that the corona is hotter where the magnetic fields are closed and cooler where it can freely escape into space. There's a Globe Observer app that you can download, and it will monitor the light intensity, so you can still do a Globe Observer even if it's cloudy. There's soundscapes, where you can record the animal, the birds, the crickets. And so there's a lot of fun things you can do even if it's cloudy. Now, if it's clear, you can also measure the spectrum of the sun, which is kind of fun. And that's one I was just telling you about, the ionosphere. This is Citizen Kate. Well, we'll be using identical telescopes with a CCD imager and measuring the brightness of the sun in the polarized light. So we did a test in Australia for 57 seconds of totality. So the first Citizen Kate was just using imaging, and that was the video that they got at, and you can see some changes happening in that hour of totality as the shadow across the Earth that the sun's corona was changing. Well, we'll be doing something similar, but now with polarized light, so we can tell more about the changes in the magnetic field direction as well as the intensity. And these are our sites, and right now we'll see how many of them get to see totalities. I'm going to skip over a couple of these things, but this is a coronal mass ejection that's coming toward Earth. And when it's coming toward Earth, you notice that it's expanding away from the solar flare. And those are the ones we hope to catch, because those are the ones that affect Earth's environment, these coronal mass ejections that are coming toward us. All right, now what do you do if you don't have eclipse glasses? There's a couple of things you can do. So this is the polarized image that we got from Citizen Kate with the polarization nearly parallel to the surface of the sun. And we'll be getting, like I said, 35 of these. So one of the fun things you can do is punch boards. You can take a piece of cardboard and punch it and get little eclipse images below it. You don't need glasses for that. You can measure the temperature before, during, and after the eclipse. You can use a sun spotter. You can have a camcorder on a TV. You can look at a reading chart. What's the smallest font that you can read as the light changes? You can photograph eclipses under trees and straw hats and monitor animal behavior. What if it's cloudy? Well, you still can measure the temperature and winds. You can still do the reading charts. You can use UV beads to see the light going away. You can still monitor animal behavior. You can watch. There's tons of live feeds now from NASA TV and Exploratorium. Even we are having a live feed from Bandera, we hope. And the main thing is don't give up. You can, sometimes they become more transparent. Now, another fun thing you can do is use projection techniques and pinhole cameras. And so one of the things you can do is, you know, take a card or and punch holes in it and then take a picture of the shadow. So like this was one that was done in Australia, and they put the date and the Australian flag on here, and every little punch hole turned into a little eclipse. But also Ritz crackers make little eclipses. Under trees can make little eclipses. Straw hats can make little eclipses all over you. And those are kind of fun things to do. Now, one thing I've invented is this solo cup projector. So you take a plastic cup or any kind of opaque cup and cut a 1/4-inch hole in the bottom and tape a lens from a pair of reading glasses, preferably 1x. So here's the cup. The lens is on this end of it, and then you take a picture of the shadow. So if you've got a 2x readers, it makes an image at 1/2 meter. If you've got a 1x reader, it makes an image at 1 meter. And so because you can get it into focus, you can have a bigger pinhole and a bigger image. So like this was from the annular eclipse with one of these 2x readers. So you can see the annular really quite good. This was the partial coming in and then in the full annular. Now, if you want a longer, bigger image, you can use a rolled up paper tube or a mailing tube and a 1/2x. And now it gives you an even larger image if you've got a 1/2x lens. So again, that's something you can do if you don't have eclipse glasses, okay? Another fun thing to do with kids is to take cookies and pop off the lids and do a timeline of what they see. If they get totality, then they can make their own little corona. Another fun things you can do is take Eclipse cards or Eclipse glasses and make masks for the kids and punch out a nose hole for them, so it keeps them protected. And these are some kids making theirs, and they can be creative and make their mask being whatever they want. So we've got some Eclipse data sheets again in my website where you can log the time and the temperature and the wind speeds, and you can also log any animal behavior. So again, to repeat, you have to use protection except during totality, and go to totality if you can, and don't give up. And if your principal won't let your kids go outside, I made a little sheet that you can embed these solar filters in, and the kids can look through the sheet and still technically be inside. There will be live eclipse feeds from NASA and from us and from the Exploratorium and probably others. So if you go to my website, I have these other links on it too. But we will have, again, we hope, a live stream coming from there. Okay, so I'll be happy to answer any questions. I don't want to go too far down the road, but the main thing is you've got to put the filters on the front end of the binoculars, not the eyepiece end. It's got to go on the front end so that you're safe. And if you've got binoculars, it's really nice to have this thing here, which is called the binocular tripod adapter. So you can put the binoculars on the tripods and share the view. All right, well, like I said, there's a lot of cool things that you can do. And I really do like putting it on a tripod, because then you can have it on the tripod and people can buy and share it. All right, I'm going to stop right. Oh, I want to show you one other thing. So this is what happens if you put your binoculars in front of your, you put your Eclipse glasses on first and then put the binoculars in front of it. It will magnify that lens and burn a hole in your glasses. So all really, really critical that your filters go on the front side of your binoculars, not on the back. Okay, well, I'm going to stop here, and if there's any questions, I'll be happy to talk about. There's a lot of fun things you can do. You can get a ball, one of those go-go balls that's got a lot of mirrors on it, and reflect the little images of the partial all around the room, and that's a lot of fun. All right, any questions remaining?
Thanks, Pat. You were doing an excellent job of answering people's questions as they went along. I think there
This
was
is one thing I do is take a pair of Eclipse glasses and cut them up, and you can tape them to the front of your binoculars. So if you don't have special Eclipse filters for your binoculars, you can cut apart a pair of Eclipse glasses, but be sure you cover up everything except the filter. No gaps and no cardboard. All right. So sorry, I didn't interrupt you. Go ahead.
Oh, no worries, no worries. I was just going to mention there was one comment, I think, when you were mentioning other things that you can see during the eclipse, like the planets and stars. We had a comment from one of our attendees who mentioned an app that you can use that can help you identify some of those. One of them is a Skyview Light, which I also use on my phone. I can also recommend Stellarium, which is a nice app that you can put on your phone or a tablet. It's a nice free app that you can just hold up to the sky, and it can tell you what you're looking at. I don't know if you know of any other apps that are good for that kind of thing.
Yeah,
Those are two of my favorites.
another one, there is an app called the Eclipse Timer, and it will count down to totality for your location, which is nice. And that's
Yeah.
a good tool. There's the Globe Observer app is one that you can download on your phone, and it will measure the light level using your phone's camera, which is cool.
Yes, that is a nice one too. Yeah.
Okay, so I had a question. He said, I'm told that eclipse glasses filters are not strong enough to use even on the front of binocular objectives. Okay. I have used them in 20 eclipses. I never had a problem. Okay. But you do have to be really sure that you've covered up everything. No gaps, no cardboard showing, only the eclipse glass. Now, be sure it's not scratched or bent or punctured, because then they don't work, okay? So if you got a pair of eclipse glasses from last year or even from 2017, look at a really bright light in your room, you shouldn't see anything, you know. The only thing you should maybe see is if you look at in the a projector, a bright room, video projector. Sometimes you can see just the filament, and then take them out and take a real quick glance at the sun. If there's any stray light at all, throw them away. But there it is, as long as you've got everything covered up except the filter material itself, you're fine.
Thanks. And I think that partially answered another question there from Tracy about if you've got eclipse glasses, you just want to do that test. Make sure if you look through them, you can see nothing else but the sun. The sun's the only thing you should be able to see.
Right. Oh, unless you got somebody welding, then you can look at their welding.
Oh, that's right.
And that reminds me, you can use welders' hoods level 14 and above. But
That's what I use for my kids, in fact. It's, goggles with the glass in them, and they can just hold them to their face.
Well, and that's why I actually like the Eclipse cards for little kids, because it's covering up more of their face. It's less likely for them to look around it, and so putting the Eclipse cards in one of those paper plate masks again really protects your kids so they can't look around it.
That's a good one.
The other thing, people, I just this morning, one of my friends says, I got some 25 times binoculars. Would they be good for the eclipse? And I said, actually, no. They're almost too high of a magnification. Because once you get to 25 times binoculars, the field of view is really, really small, and it's hard to find the sun when your field of view is only barely bigger than the sun. And even if you put them on a tripod, you can use the shadow to align it, okay? But the Earth is rotating, so that sun is going to drift off through your field of view pretty fast. So in my experience, 6 to 10x binoculars are comfortable and easy to use. Now there's a 2x binoculars that I really like that pop up. They're made by Celestron Eclipse Smart, and you squeeze them and it makes just a 2x, and it's great for kids because it's easy for them to find the sun, and yet it gives you some magnification. And they're like 2 for $12 if you can still find them, but a lot of them are sold out.
Let's see, there was a good question about some activities to do when you're not under totality. So basically, if you're seeing the partials, I think you mentioned a couple of good ones. Of course, the pinhole projecting is a wonderful activity to do with kids, I think.
Yeah, and you can still do the temperature changes, Generally speaking, it doesn't appear to get really dark till it's about 90%. Up till like 80, your eyes are kind of are just kind of adjusting, like it's going to be a storm or like it's going to be sunset. But once you get about 90, it really starts to feel weird. So it gets dark, but it's not red. Normally when it's that dark, it's sunset and everything's a little bit red. So everything looks a little weird blue, and the shadows get really, really sharp. And again, if you're in the 80, 90, you can watch for animal behavior. But you won't get the corona unless you're in totality.
Right. One of the other activities we can suggest, and we have them on the Space Weather Explorers Week website, by the way, there's several activities, but there's UV beads are great to use with kids out there to think about sun safety. So if you're not in the path of totality, and there's several nice things that you can do under the real sun. You could do modeling activities using some balls as the moon and yourself as the earth, and you can use the real sun to model an eclipse. If you're getting rained out there, you can just get a light bulb and do the same thing indoors. Let's
And
see, we
watch
don't
it
have
on
a,
TV. And watch it on TV.
oh yeah, absolutely. Yeah, check out the live streams for sure from NASA. Pat and I were just looking beforehand at what NASA's offering. So if you go to nasa.gov on the day of, there will be their live stream, which they have 15 different observation sites. And so clouds may affect some of those, but they're not going to affect all of them. So we'll be able to see at least some of it through the live stream. So for sure, you should check that out. Let's see, there was one question that I wanted to make sure. There was a question about, oh, the rainbow corona that you were showing there, if, like this behind you, the polarization effect.
Yeah, okay. There's something we're actually going to try on one of our telescopes, and that is now during totality. Okay. Now I said don't use your sunglasses during partial, but if you're in totality, try putting your sunglasses on, and now tilt your head. Okay. So the sunglasses will block out a little of the corona, so it'll be dimmer. But it will look different if you turn your head this way than if you turn your head that way. So you're kind of reproducing that colored uh, 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 polarization rainbow around the sun. But that's false color. In other words, they took yellow to be this polarization and blue to be this polarization and green to be that polarization, and then digitally added up the images to make the pretty rainbow. Okay, so you're not going to see that with your eyes. That's you have to do post processing on that. Okay,
Right. So
but
if you're using the polarized lenses, what you'll see when you turn your head is you'll see the brightness
change.
change as you tilt. Yeah.
And did you know that the moon itself has polarized light? Sometime on a full moon, go out and look at the full moon with polarized glasses and turn your head to the left and to the right and see how different the moon looks.
Oh yeah.
Because
The
moonlight.
regolith gets charged up from the solar wind, right?
But yeah, you can buy sheets of polarization filter just like you can buy sheets of solar filters. But the polarized filters are only during totality. In the partial phase, you have to use real solar filters, not the polarizing ones. And you can't even just take two polarized sunglasses and cross them. That does get rid of a lot of light, but not enough. But yeah, I have an Eclipse email list group that you can join. It's all on my website, and I'm happy to, and I'll be sending out more bulletins as we get closer.
Great. There's several good questions here. I don't know if we're going to have time for all of them. There's at least one I want to make sure that people gets answered. Someone was wondering about, even in totality, is the corona too bright to damage the eye? And the no, it isn't, right? The
No,
corona is totally safe to look at with your eyes, no filters needed.
it's about the same brightness as the full moon. Okay, so you've seen the full moon all the time, so it's perfectly safe.
Yeah.
But it's so because it's so much dimmer than the sun, it's actually there all the time. We just can't see it most of the time because it's so much dimmer than the sun, and our sunlight gets scattered by our atmosphere. So we can't see it the corona normally. But on a top of a very high mountain, when you're above most of the atmosphere, then they can put a disc in front of the sun and get a picture of the corona because you're above so much of the atmosphere. Now, is there an ISS? I don't think there's a good ISS overflight, but I heard there was one kind of nearby. So I don't know whether they're going to be able to see that or not.
Right. Yeah, they have a feed from the ISS, and the time it takes for the path to cross the continent is around 90 minutes, which is also about the time it takes for the ISS to orbit the Earth once. So they'll see the shadow falling on the Earth, and they're going to have cameras pointed at it. So NASA will show that. I don't know if they're actually passing under the shadow themselves.
I don't think they are. It would be really amazing. That would be amazing luck.
Right. Yeah.
Uh,
Okay, well, I think we're at the hour mark, and so I want to give everyone the rest of their day to start planning, making their plans for the eclipse. Thank you so much, Pat, for all of that wonderful information. Please check out her website for all those resources she shared with us today. And you can also check out the Space Weather Explorers Week website for additional activities and resources. After the webinar closes, your browser will point you to a survey. If you wouldn't mind filling that out for us and letting us know what you liked and what you would want more of, because we want to make sure that we're providing you with the best resources we can. And please feel free to ask us questions at the Discord site that we have set up for Space Weather Explorers Week. All right, and with that, thanks again, Pat, and everybody, good luck observing the sun and the solar
enjoy.
eclipse next week.
And if you can only see a partial, enjoy it.
Indeed. Thank you so much.
Bye-bye.